All right, welcome back to week 2 of quarter 4. Today we're going to talk about simplifying rational expressions. So last week it was about finding the domain of a rational function. Now we're just going to switch and just think about expressions. So nothing that we can solve, nothing that we need to find the domain for, just something that we need to simplify. So the way that we're going to approach this is we have a fraction here. It's 12 over 16. And there are basically 3 different ways that we could simplify this fraction. One is we could grab a calculator, and we could go over to a calculator and we could just put in 12 divided by 16, and it's going to give us a decimal, 0.75. And that's perfectly fine. That's a perfectly fine way to simplify a fraction when you have just numbers in it. And in this case, it's okay to do it because it's a decimal that terminates, it stops, it doesn't continue on forever. If it were to continue on forever, we generally don't like to use a calculator because it's going to give us a number that we have to round in some way. And rounding introduces error, and we don't always like error. So that's one way that we can simplify a fraction, or a rational expression in this case, because it is a fraction, it is an expression. The second way we can simplify this fraction is to simply just divide by a factor. All right, so we're going to divide by a common factor. So if we think about 12 over 16, both of those numbers are divisible by 4, so we can divide each one by 4, and we end up with 3 over 4. So we have simplified that. It looks different than what we did with the calculator because it's still a fraction, but it is still the same as what we did with a calculator because 3 over 4 is 0.75. And then the third way that we can simplify this fraction is by factoring. And factoring is going to be very similar to what we just did. However, when we factor, what we're going to do is we're going to change this fraction into multiplication that involves a common factor. So we can use the one that we just did to help us, because if we notice, when we divided by 4 we got 3, when we divided by 4 we got 4 in the numerator and the denominator. And so we're going to do the same thing. We're just going to say, all right, this, I can rewrite 12 as 3 times 4. I can also rewrite 16 as 4 times 4. And then anytime we have a common factor in the numerator and the denominator, we can cancel those common factors. So I'm going to cancel the 4 on top and only one of the 4s on the bottom. We can't cancel both of them, just one of them. And then I'm going to rewrite with what we have left. So it's 3/4. All right, so these 3 different ways that we can simplify a fraction like that, we can also apply to an expression that has numbers and variables in it, but we can't use a calculator because we can't do variables on the calculator. And dividing by a factor isn't always going to work because, well, it'll work for the numbers, but it won't necessarily work for the variables. So the way we're going to do this is we are going to factor this expression to simplify it. So what I mean is we're just going to do exactly what we did in that last box for the numbers, and then we'll simplify the variables a little differently. So what I'm going to do is rewrite the top as 1 times 5, and then I'm just going to go ahead and write out all the z's. I know it's kind of annoying, but hey, we need to do it sometimes. And then I'm going to write the 10 as 2 times 5, and then I'm going to write 5 z's. Okay, and then what I'm going to do is I just need to cancel all the common factors. So the common factors are the 5s, and then we have 1z. Wait a minute, I didn't cross that top one off very well. We have 2 z's that are the same, we have a third one, and we have a fourth one. Okay, so now I didn't cancel that 5 very well either. I better do that. So now what we're left with is we're left with that 1 up top, and that's why I wrote 1 times 5. A lot of times we don't write 1 times 5 because there might be something else that's going to still be left on the top. But I knew looking at this one that there would be nothing else left on the top, and sometimes that leads to some confusion. And so I did that 1 times 5, so I know there's a 1 left in the numerator. And then in the denominator, you can see I just have a 2 and a z, so there's 2z in the denominator. Okay, so that's a method for factoring a rational expression with numbers and variables. Now, hopefully, what you can notice from this is that we have a exponent of 4 on the z in the numerator, an exponent of 5 on the z in the denominator, and 5 minus 4 is 1. And when we do that, we end up with 1z, right? And it's in the denominator because the 5 is bigger than the 4. So this is something that we can use, and so we don't have to write out all those z's like I did. All right, let's fill in the blanks here with a little bit. So it says, what is simplifying rational expressions? Well, it's simply reducing a rational expression to simplest terms by factoring the numerator and denominator to what? I'm trying to remember what I was intending for. I know what the second one is, but so we're going to reduce a rational expression to simplest terms by factoring the numerator and denominator to, you know what I'm going to do? I'm going to cross off that one because I don't know what goes there. So we are just going to eliminate common factors. Okay, so the whole idea is we factor like we did above so we can cancel common factors in the numerator and the denominator. And then common factors may be numbers, variables, or expressions. Okay, and when I say expressions, I mean things like binomials. If we can find 2 binomials, one in the numerator, one in the denominator, and they're the same, we can cancel them. Okay, so we're going to start off right away with a really stiff one, and we're going to factor this thing. So you can see right away, it's like it doesn't look anything like we did up above because we've got plus and minus signs in between terms in this one. So we have a trinomial in the numerator, trinomial in the denominator. And what we need to do is we need to take a look at this and factor it. And if you remember from factoring, we can factor this thing into 2 binomials. So I'm going to go ahead and create 2 binomials here for the numerator at least. I'll actually, you know what, I can do both here. Because I know anytime I have a trinomial, or anytime you see a trinomial, you should probably think 2 binomials. That's usually what's going to happen. We're going to factor it into 2 binomials. All right, so the numerator, I can pretty easily figure out what goes in the binomials from the 5x squared because there's only one way to make a 5. It's 5 times 1, right? So I know that I'm going to have a 5x and a 1x. All right, but then I have to look at the 6, and I have to say 6 can be made by multiplying 1 and 6 or 2 and 3. And then I have to figure out, okay, if I multiply the 2 by 5, it equals 10. Ooh, plus 3, 13. All right, so that kind of gave us what we needed. So I know that I need to multiply the 5x times 2. So I'm going to put the 2 over here because when I distribute it, it's going to be 10x, right? Okay, I'm going to get rid of that. And then I'm going to put the 3 over here, and when I distribute here, it's going to be 3x. 10x plus 3x is 13x. So that's the relationship that I want there to be able to get the 13x, right? So I factored the numerator, and now when we factor the denominator, what I want you to think about is we're always looking for stuff that we can cancel or we can eliminate, right? And if I've already got 2 binomials, if I already know 2 binomials in the numerator, I'm kind of thinking that one of them is going to be in the denominator as well. And if you look at these 2 binomials that I'm dealing with here, 5x plus 3 or 1x plus 2, there's only one of them that could possibly be down there, and that's the 1x plus 2, because the 5x plus 3 wouldn't make sense, because there's nothing I can multiply 5 by to turn it into a 6, right? So I know I'm going to have a 1x plus 2. So I'm just going to go ahead and put the 1x plus 2 down here, and I'm going to put it first. I could put it second, I suppose, to have it right beneath the other one, but it's like, I don't know. I like to put it in the first spot. Okay, and then what we can do now is we can say, all right, I've got a 2 in there. 2 times negative 5 is equal to negative 10. And then 1x times 6x is equal to 6x squared. So this is just kind of all guessing, right? At this point, we don't know for sure if it's going to work. But if we just do a little distributing here, so if I distribute from here to here, I get negative 5x. And if I distribute from here to here, I get positive 12x. So if I take negative 5x and add 12x, I get 7x, which is what I want. That's the middle term in my trinomial. So I'm going to go ahead and get rid of that so it's not in the way here. Let's get rid of that. Boom, there we go. All right, so now that I have the binomials, I can look at that and say I have a common factor. And you might be wondering, well, there's a lot of stuff going on. How do you know those are common factors? Well, because this binomial is multiplied by this binomial, and this binomial is multiplied by this binomial. So whenever you have multiplication like that, it doesn't matter what's inside. We can eliminate things that are common. Okay, so in this case, our common factor is parentheses 1x plus 2. And so I'm just going to go ahead and eliminate that. And when I do, I end up with 5x plus 3 over 6x minus 5. And that is as simple as I can make this expression, because 5x plus 3 and 6x minus 5 don't have any common factors. Okay, so that's about as hard as it's going to get when it comes to factoring these things. Although I should be careful, because we also have to use SOAP, if you remember SOAP from before. So let's go look at some more examples. We got a bunch of examples to do. How many are there? There are 6 of them, right? All right, so let's go ahead and do these 6 examples. Now, some of them are going to be different. They're going to be quite a bit different. Okay, so this first one starts off quite a bit different. So what I am looking at here is I'm looking at a monomial in the numerator and a binomial in the denominator. And you can notice that you've got some common factors in the denominator. And one thing to point out here is anytime you have a monomial like this, I would always try and factor that monomial from the numerator out of the denominator. So I'm going to rewrite this as, now I'm going to do this, and some of you are going to wonder why, but it's like, you'll see in a second. So I'm going to write that as 1 times 2x squared. It's kind of the same reason why I did it up above. And then the denominator, I'm going to try to factor that 2x squared out. So when I factor a 2x squared out of a 10x to the third, that means it's 5x, right? And then 2x squared out of 2x squared. And this is one where people can make a little mistake. They think sometimes when we factor a 2x squared out of that 2x squared that it goes away, but it doesn't. It becomes a minus 1. Because we have to always think, okay, what now if I were to distribute, will I go back to what the original denominator was? And the answer is yes, because you're going to get 10x to the third minus 2x squared. All right, so since I now have things factored completely, I can notice that I've got a common factor that's 2x squared. And this is now why I wrote that 1 times 2x squared up above. So what's left here is 1 over 5x minus 1. So I have simplified this expression down to 1 over 5x minus 1. Okay, so the whole idea of simplifying is you're just creating an equivalent expression, and it would be a lot easier to work with the simplified expression than it would be to work with the original expression. So if you think about having to plug numbers into this thing, I'd much rather have to plug in x only once than a whole bunch of times like you'd have to in the original expression. All right, let's look at another one. Okay, so we go right back to the same type that we did on the previous page. We've got trinomials. So when we've got trinomials, we need to think turning them into binomials. So I'm just going to go ahead and create some binomials. So anytime you have trinomials, I want you just to think this way. And now you can start either place. You can start in the numerator. You can start in the denominator. It kind of depends on which one you feel is going to be easier to do. Or if you just see one right away, you can be like, oh, wait, I know what this one's going to be. And, for me, it's the denominator. I look at that denominator and I say, I'm pretty confident that this is going to be 8x here, 1x here. I didn't say it up above, but you don't necessarily have to write that 1. You could just write an x if you wanted to, but I don't know. I like to write the 1 sometimes. And then I have to get to a -7. There's only one way to make a -7. It's going to be 1 and 7, but one of them has to be positive, one of them has to be negative. If I put the 7 here, the problem I'm going to have is 8 times 7 is 56. So that gets me way too far away from the number that I want, which is just 1. So I'm thinking the 7 has to go here, the 1 has to go there. And I'm kind of thinking this one needs to be negative and this one needs to be positive. And we can check it out. We can say, all right, 8x times 1 is 8x. -7 times 1x is -7x. If we subtract them, we get 1x, which is the same as x. So we have the right thing. All right, so I'm going to go ahead and get rid of that so we don't have that in the way. There we go. Now, what I need to do is I need to say, all right, which one of these two binomials from down below is most likely going to show up above? Well, there's only one choice. It's the 1x plus 1, because 8x, there's no way I can multiply 8x times something to turn it into 9x squared. All right, and so now this is going to be relatively easy because I've got the two numbers in there. Now I'm just going to put whatever other numbers I need. So I know I need a 9x here, and I need a plus 4 here. And then we just have to double check it and see if it works. So we have, oh, I don't want to do that one. I want to do this one. Whoops, too many dots. I want to do that one, which is 4x, and then this one plus 9x. And that clearly works, right? It equals 13x. So I know I have the right binomials in the numerator. Okay, so then I can just do what I did up above, where I just cancel. I cancel. So this whole expression simplified now becomes 9x plus 4 over 8x minus 7. And hopefully you'll notice that I didn't use parentheses in the answer on this one. And that's okay. You can use the parentheses if you want, but you don't have to. All right? I generally don't like to use them, but it can get a little confusing for some people if I don't, so sometimes I do. All right, let's do another one. You might be wondering, what the heck? How are we going to do anything with this? Well, the first thing I'm going to do with this one is I'm going to rewrite the top, or the numerator, so that it's in the same order as the denominator. It annoys me when things are not in the right order. So I need to, whoa, too big. I need to move the -x in front of the +2. Okay, so that's one thing to remember. This is a +2. Okay, so it's going to become -x plus 2 over x minus 2. And you might be wondering, how the heck am I going to be able to cancel something here or eliminate something here? Because they look completely different. But imagine if we could just change the signs in the numerator so it became a +x and a -2. Then we could eliminate the x minus 2. Well, there's a way we can do it. If we just factor out a -1. And this is kind of an unusual thing to do, so people don't necessarily think of it right away. If we can factor out a -1, and when we do, the -x becomes +x, and the +2 becomes -2. and then we have the x minus 2 on the bottom. And now I suppose this is a good example too, because I've got a parenthesis on top. I don't have the parentheses on the bottom. And some of you might be thinking, well, does that make them different? Nope, they're still the same. But I'm required to have the parentheses on top because I actually factored out a number and it's sitting on the outside and it's multiplied by it. So I can do this even though they both have parentheses. So I'm going to eliminate the x minus 2's, and what I'm left with is just that -1. So this whole thing simplifies down to -1. I suppose you could test that theory out too if you wanted to. You could take that original and say, hey, wait a minute, what if I plug in a 3? 2 minus 3 over 3 minus 2. Well, 2 minus 3 is -1. 3 minus 2 is 1. -1 divided by 1 is -1. So it makes sense. All right. Let's keep going. Now, I do move fairly quickly through these, but if you're virtual, you have the luxury of just being able to stop the video if you want and be able to rewind it and go back and watch part of it again. All right. Let's see here. What are we going to do with this one? So this one has a trinomial in the denominator. It has a binomial in the numerator. There's nothing obvious that stands out that we should probably do first. So I would suggest we just factor something. So I'm just going to factor the numerator. Oh, I see where this is going. All right. This one's tricky. Let's do this. We'll factor the numerator. And so really the only thing I can do with the numerator at this point right away is factor a 2 out. They're both even numbers. 18 and 2 are even, so I'm going to factor a 2 out. So I have 9 minus x squared. Okay, and then let's factor the denominator. And the denominator is not too bad because it's a trinomial. It's got -3. So this one just factors into x minus 3 and x plus 1. And now we're staring at some work that we did, and we're like, nothing's the same. There's nothing I can cancel. And you're right, there's nothing we can cancel. But if we notice something, the numerator has a binomial that's the difference of squares. And we can factor this thing into 2 binomials. So we can say, all right, we can say it's 3 minus x and 3 plus x. Okay, and then we have x minus 3 and x plus 1. I said this one was tricky, and I wasn't kidding. Now we're looking at it and we're thinking, well, wait a minute, it doesn't work. Nothing's in the right order. So let's do this. Let me see here. I'm running out of room. So we're going to come down to the next row. So what I'm going to do is just rearrange the order of the ones on the top. So we have negative x plus 3 and x plus 3. Maybe this will help. Maybe it won't. Well, that didn't do any good. But then I'm going to notice that thing that I just did on was it the last problem? Where I factored out a -1. I can factor out a -1 out of that thing. And it's going to change it into that one. Okay, so I'm just going to go ahead and factor a -1 out. Now, I can show all the steps, or we can just say, hey, when I factor a -1 out and that 2 is already sitting out there, it becomes 2 times -1, which just makes it a -2. So I'm just going to go ahead and jump right to -2. So that 2 becomes negative when I factor the -1 out. And then we have x minus 3. Whoa. X plus 3. And then that's all over x minus 3 and times x plus 1. Wow. I wasn't kidding. It is tricky. There's just lots of steps. And I think some of you guys get frustrated with lots of steps. But now we're down to a point where we can cancel this binomial and this binomial. And what we're left with is negative 2 times x plus 3 over x plus 1. I'll put it in parentheses for y'all. All right, that was a lot of work. But it's stuff that we all know how to do. So we should be able to do that. Oh boy. All right. I see a problem on here that I shouldn't have left on here. Okay. Maybe I'll do it just to show you, or otherwise, I don't know. This video is getting a little long, so maybe I won't. All right. Here's what we're going to do. We now have one here that has x to the third. And x to the third, remember, that requires us to use SOAP. Same, opposite, always positive. And we have to remember, a squared, b squared, right? And then we have, wait a minute. No, it's AB, sorry. Whoops. AB, A squared, AB, B squared. Oh, I'm infringing on that other problem. Okay, you know what I can do? Here, let's do this. Whoops, no, that's not gonna work. Back up, stop. There we go. We'll move it. There we go. What? It didn't move. Why did it do that? Oh well, we'll leave it where it is. All right, so factoring the numerator. So to factor the numerator, remember x to the third. Okay, that means our a is equal to x. And 8 means our a is equal to, well, we have to do a little work here. 8 is 2 to the third power, so our b is equal to 2. This is ringing a bell. You guys remember this? Hopefully. All right, and then we can take our SOAP and we can create our binomial and our trinomial. So we have a and b in the first one. So remember, it's the same sign. So we have a plus sign in there. So we're gonna have a plus b. So we have x plus 2. And then we have a squared, so that's x squared, plus a times b. It's a times b, but I'm gonna write it in the order of b times a. So it's minus 2x because we have the opposite sign. And then we have always positive, and we are going to write our b in there. So we have just a 2. Okay, so there we go. That's the numerator. Completely factored. All right. Kind of messy, but, you know, we got there. And then the denominator, what I'm going to do is it's backwards, so I'm just going to flip the order. They're both positive, so nothing's going to change. They're both going to be positive. And we can see I just have to eliminate a common factor of x plus 2. So my answer to this one is x squared minus 2x plus 2. That is the simplest form. And now you might say, wait a minute, that's a trinomial, Mr. Egbert. Can't we factor that trinomial? Well, we could try. 2 can be created by 1 times 2. But then we have to think, can I add those two numbers together to get to negative 2 or subtract them? And the answer is no. So that means that this is already in simplest form. So we have to stop there. All right, one more. Now you might be looking at this and thinking, hey, that thing's got 4 terms in the bottom there. I don't know how to do anything with that. And that's okay. I didn't show you how to do this method, so I'm going to make this problem very easy. If you really want to know how to do this, let me know. But the easiest way we can do this problem is just say, no, let's not do it. So we're going to cross it off. If you want to know how to do it, let me know. I will show you. Come to my office hours, 9 to 10, Monday through Friday, or anytime by appointment on Friday. All right, you got an assignment here. Again, there's a couple of challenge problems at the end that are different. And this is what I expect you to be able to do. So on that test that we're going to have next week, there's going to be problems like this. And so make sure you do these challenge problems. And if you're struggling with them, come to my office hours.